In this video we're going to finish the proof of the snake lemma. So here was the statement. We had a short exact sequence of chain complexes and chain maps like this, and then the claim is that there's a sequence of these maps, connecting maps delta from HNW to HN-1U, with the property that this long twisty sequence here is exact everywhere. So what we've done so far, we proved that the sequence is exact at HNV. In other words, the image of this I lower star is equal to the image of P lower star. That was the first step. And then we spent some time defining this map delta in terms of the group of snakes. And so then that leaves us with two more steps to prove. We need to prove here that the image of this P lower star is equal to the kernel of delta. Its exactness at the point HN at the group W. And then we also need to prove that the image of delta is equal to the kernel of I lower star. In other words, you need to prove exactness at U. Okay, so now let's prove exactness at W. Okay, so we want to prove that the image of this P lower star is equal to the kernel of delta. Okay, so first way around, we've got some. We want to prove that this composite delta composes P lower star is equal to 0. That's half of what we need. So we've got some B over here. So B is an element in HNV, so it can be expressed as square bracket W for some cycles of V. So V is in Vn with dV being 0. Okay. So we want to prove that delta of B is delta P star V is 0. Okay. So we take this P star B, we want to prove that delta of it is 0. In other words, we need to show that there's a snake that starts with P star B and ends with 0. That's how this map delta was defined. Remember, we have to construct a snake that starts with the first thing, and the end thing is going to be delta of it. But then it's easy to produce a snake that starts with P star B. Okay, so I want to claim that this is such a snake. So the first condition is that you've got P star B, which is a homology class, and we need to find a representing cycle. So, but by definition, P star B is just equal to square bracket PV. So PV is the relevant representing cycle. And then we need to find some V that maps to this under P to this PV. Well, of course, we just take it to be little v. And then we want dV to be IU. Okay, but dV is just 0 here. Okay, so we can take U to be 0, and then dV is IU. And then this last element is supposed to be the homology class of that U that we had there. But the homology class of 0 is 0. So that means that this is indeed a snake, and it starts with P star B. So according to the definition of delta, delta of P star B is 0. Okay, so that means that delta composed with P star is just 0, and that's equivalent to saying that the image of P star is contained in the kernel of delta. So now we need to do it the other way around. So we've got C being in the kernel of delta. We need to prove that it's also in the image of P lower star. So C is in the kernel of delta. In other words, delta C is 0. According to the definition of delta, we're supposed to find a snake that starts with C and the end is delta C. So if delta C is 0, then there must be a snake like this, C, W, V, U, and then 0 on the end. Okay, so let's unravel what it means for this to be a snake. Okay, so the kind of last snake condition says that the homology class 0 is equal to square bracket U. Square bracket U is 0. But remember, square bracket U is just the coset with respect to the group of boundaries with respect to the image of D. So if square bracket U is 0, then U must be equal. It must be a boundary. It must have the form du prime for some U prime in UN. Then we're working backwards through the snake conditions. The next snake condition says that dV is IU. But U is du prime, so IU is IDU prime, and then I is a chain map, so that's DIU prime. So we've got dV is equal to d of IU prime. In other words, the d of V minus IU prime is 0. Okay, so that means so this V minus IU prime, okay, that's a cycle. cycle in the chain complex V. So it has a homology class, which we can call B. B is square bracket V minus IU prime. That's a homology class in HNV. So that's good. We want to claim that P star of this homology class is equal to this C. So what is P star B? Well, by general recipe for P star, we just move the P inside the square brackets. You get P of V minus IU prime. But remember, the sequence I followed by P is a short exact sequence. So that means in particular P composed with I is 0. So this PI term is going to go away. And then PV is equal to W. You see, that was the again, that was one of the snake conditions. CWVU is a snake. Second condition for that is that PV has to be equal to W. Okay, so in this here, you've got PV minus PIU prime. PIU prime is 0. PV is W. So this can be written as P star B is square bracket W. But again, the first snake condition is just that this C here is equal to square bracket W. So square bracket W is C. So we've seen that P star B is equal to C. C is in the image of P star. So that's the other half of what we needed. That the kernel of delta is contained in the image of P star, and then here the image of P star is contained in the kernel of delta. So they're the same as claimed. So that proves exactness at W. And finally, we need to prove exactness at U. Okay, in other words, that this sequence delta followed by I lower star is exact, or the image of delta is equal to the kernel of I lower star. So firstly, we want to prove that just that this composite delta, if we do I lower star composed with delta, that should be equal to 0. So we start with an element C here. Okay, and we want to think about delta of it. So we have to choose a snake that starts with C and ends with A, say. So that means that delta C is equal to A, and A by the snake conditions is equal to square bracket U, and then also by the snake conditions IU is going to be equal to DV. Okay, so that tells us what delta C is, and we want to know what I lower star delta C. So I lower star delta C, that's I lower star A, or I lower star of square bracket U. And the general prescription for I lower star, we move the I inside, so that's bracket IU. But then we also have this condition here, IU is DV, so that's bracket DV. And again, square brackets indicates cosets modulo the image of D, so bracket D anything is always just the 0 class. So we found that I star delta C is just 0. This shows us that if we do delta composed with I lower star, that's just equal to 0, and therefore that the image of delta is contained in the kernel of I lower star. So now we have to do it the other way around. Okay, we have to prove that the kernel of I lower star is contained in the image of delta. So we choose a class A in the kernel of I lower star. Okay, so A is a homology class over here. In Hn-1u, so we can choose some representing cycle. U is in Zn-1u, so A is square bracket U, du is 0. If we look at square bracket IU, then that's just the same thing as I lower star A, but I lower star A is assumed to be 0 because A is in the kernel of I lower star. So that means that this coset, bracket IU, is 0, or in other words, IU lies in this group Bn-1V, or in other words, IU can be expressed as dV for some element V, which works out to be U is in UN-1, IU is in Vn-1, so this V here has got to be in Vn. Okay. So now we're going to define our little w to be P of V, so that's now an element of Wn. And if we look at dW, that's the same as dPV, just by the definition of W, which is the same as PdV, because P is a chain map, which is the same as PIU, because of this equation here. But remember, we are I and P form a short exact sequence, so in particular P composed with I is just a 0 map, so this PIU is just 0. So we see that dW is 0, That means that W is a cycle, and so it's meaningful to define C to be square bracket W. That's a class in HNC. So now we've built all this up step by step in such a way that this CWVUA is a snake. Okay, so this means, because we've got the snake like this, that means that A is going to be equal to delta C. Right? To find delta C, we just have to find a snake starting with C, and then the end point is delta C. And here's our snake, and it ends with A, so A is delta C. So in particular, at A, that's going to be in the image of delta by this equation here. Okay? So this paragraph proves that the kernel of I lower star is contained in the image of delta. This first paragraph proves the inclusion the other way around. So the image of delta is equal to the kernel of I lower star, which is what we were supposed to be proving. Okay, so now we've got exactness at U. The previous slide proved exactness at W, and then several in a previous video, before we even bothered to introduce the definition of delta, we were able to prove that the image of I lower star is equal to the kernel of P lower star. In other words, that's exactness at V. So now we've checked exactness everywhere, and that completes the proof of the snake lemma.